All right. Hope everybody's having a good day. Looked like a lot of grades on that exit ticket were coming back pretty well. Did anybody get a 100? Few folks? Okay, good, good, good. But like I said, that is what you can expect Thursday on your quiz, dot products, vector projection, the angle between two vectors, so you need to know all those formulas, all that good stuff. Then next week, on Thursday the 28th, that's your second exam, but it won't cover vectors. I actually did not put any vectors on the test. It's going to be all this material right here, sequences, both arithmetic and geometric. Okay, so let's see. What is a sequence? It was an ordered progression of numbers. We talked about they can be finite or infinite. The formulas we were using, they could be either recursive or explicit. What was the difference between the two? Like, how did recursive work?
You had to like start from the very.
Okay, so recursive formula has to rely on finding the previous term. You have to know the previous term in order to find the current term. So in a recursive formula, if I wanted to know, say, the 15th term, I would have to start with the first, find all the way through the 14th, which would then allow me to find the 15th. Okay, it's always based on the term immediately prior to what you're looking for. But explicit, that is something completely different. That formula will immediately find any term number that you want. You don't have to know the previous one. And typically, it goes ahead and starts with the first one. All right. And then we kind of brought up the idea of converging and diverging. We'll talk more about this tomorrow when we can actually get to some examples. But if you start to analyze the pattern of your sequence, if it looks like it's approaching a specific number, we say it converges. If it's not approaching a specific number, then it diverges. Okay, we've got geometric and arithmetic. If you are multiplying each term by the same value over and over again to generate the sequence, we call that value the common ratio, and we use R to describe it. If it's an arithmetic sequence, well, then you're either going to be adding or subtracting the same value over and over again. We call that the common difference, and we refer to it as D. And then we talked about our formulas here. We have the two explicit up at the top, this main explicit one down at the bottom, okay, and either one, whichever you're most comfortable with. We've got a couple of recursion formulas here. You can either write it as a subscript n plus 1 or n minus 1. I actually prefer the n minus 1. For me, it just makes more sense, but either way is going to be correct. And then I think we got away with one problem, right? Okay, so we are on number 2. Find the common difference, the 10th term, a recursive rule, and an explicit rule for the nth term, 5, 8, 11, 14, 17, dot, dot, dot. Okay, so let's go ahead and number these so we can keep track of everything. So let's say the first part is the common difference, 2 is finding the 10th term, 3 recursive, and 4 explicit. Okay, well, how am I going to go ahead and figure out what the common difference is? What do I do with consecutive terms? Yeah, we're going to go ahead and subtract them. And see, here's the thing. In the beginning, a lot of times, I'll probably go ahead and tell you this is an arithmetic sequence, this is a geometric sequence, so you'll know you're going to be adding, subtracting, or multiplying. But then eventually, we're going to get to the point where I'm not going to be giving you that information, and there's really no straightforward method to tell. It has to be one of the two. You're either adding or subtracting or multiplying, and you may have to do a little bit of analysis. Okay, how am I moving from one term to the next? What am I constantly doing to generate the sequence? Okay, so here, if I know it's arithmetic, well, all I got to do is take consecutive terms and just subtract them. Always subtract the one prior. So if I started with 17, I'm going to subtract 14. That would give me what? 3. And then take another pair. 14 minus 11 will give me 3. 11 minus 8 will give me 3. Well, you'll notice I'm getting the same difference over and over. So that's why we call it the common difference. That value that I get, that's D. Okay. So all I'm doing is just adding 3 to get to the next term. Okay. Questions on that? Easy, right? Okay, well, now we want the 10th term. Now this one, I mean, you've already been given the first 5. You easily could go ahead and just add 5 more times to go ahead and get to the 10th. But let me go ahead and show you how to do this algebraically, because a lot of times it's not going to be that straightforward. Let's use these two little rules right here. Okay. Now we already know the first term is 5. We already know that the common difference from a moment ago, we know that's 3. So let's plug in here, because ultimately we want this expression. We want that linear function. Okay. So let's see. C is equal to the first term, 5, minus the common difference, 3. Okay, so C is 2, and I want to put it in this form. A sub n is equal to dn plus C. Well, I already know D and C, so just go ahead and plug in. What would that function be? What is D? 3. So dn would become 3n plus C plus 2. Okay. So this right here should be able to find me any term I want in the sequence. Okay. This is what you're saying?
Oh, yeah.
Okay. Now this one, we're wanting the 10th. So I'm going to go ahead and say 10. Remember that little subscript right there, n, that's the term number. So I'm just going to plug in. So 3n becomes 3 times 10 plus the 2. So I should be getting what? 32. Now I also wanted to go ahead and do it this way to show you that explicit formula, because when we go ahead and plug into the general form in the fourth part, I want to show you that you're still going to be able to simplify and get the same rule. Okay, that there won't be any change there. Okay, questions on the second part? Okay, now the third part, this is where we want to write the recursive formula. Well, if you're going to write a recursive formula, you always have to identify the first term, because this formula always works on the previous. So in order to find the second, I would need the first. Okay, in order to find the third, I would need the second, and so on. So the first term is 5. Okay, now there's two different ways you could write it. Let's go ahead and write it in this fashion right here. Let's use this formula, the n minus 1. So I'm going to go ahead and say, okay, the nth term is going to be a sub n minus 1. See, the previous one, whatever term number I'm looking at, if I subtract 1, that's the previous. But what am I going to add to it? Remember the formula, I heard some people saying it. The formula says to go ahead and add d, but we found that to be what? 3. So all I want to do to find the current term is take the previous and add 3. But now we also want to go ahead and make sure we put our restriction. N has to be what? Greater than or equal to 2. And typically, probably the majority of the time, that's going to be your restriction. You'll notice we've already seen one that's different. On the previous problem, it was n greater than or equal to 1 because of the way it was written. But if you're going to use this formula, you'll probably use n greater than or equal to 2. Like, for example, we can't say 1 because what's 1 minus 1? 0, and we talked yesterday about the 0th term. And while some people do use that, we will not. I'm just going to start with the first term and move on. Okay. And then now let's get to the last part. Okay. So we want an explicit rule. Now, I'm going to use the general form that I was taught a really long time ago. So a sub n is equal to, remember you take the first term plus the difference of the term number and 1 times the common difference d. Okay, this is the formula that I like to go ahead and use more than anything else. Well, remember, we saw one of these yesterday. If I want to come up with a general form that will get me any term, I'm going to plug in all of my variables except what? Do not plug in for n. That is exactly right. Plug in everything but n. So a sub n equals, what was the first term? 5. Okay. Plus, we're not going to touch n. N minus 1 times d again was 3. Now remember, we'd actually already come up with an explicit form because of the second part. So when I simplify this, I should be able to get the exact same thing. Somebody triple n minus 1 for me. That would be 5 plus what? 3n minus 3. Okay, and when you add your constants, you do get 3n plus 2. See, that is exactly what we got just a little while ago. Okay. Anybody having a hard time? Any questions? Okay. Now, the notes here are pretty interesting From that problem, it goes immediately to talking about geometric sequences. We go ahead and introduce the formulas, but then the two problems that follow it are both arithmetic sequences. So we're going to do a little bit of skipping around here. Okay, we're going to go ahead and do numbers 3 and 4, and then tomorrow we'll go back and I'll actually go ahead and show you the geometric formulas. So these two, I'm going to tell you they are arithmetic. Find the first 6 terms on the 100th term of the sequence in which a sub k is equal to k squared minus 1. So you're looking at that expression, you know it's a quadratic, so your first instinct would not be to think that it's arithmetic, but it actually is. I'm going to show you how in just a moment. But as far as the problem goes, I just want right now the first 6 terms. So the first thing I'm going to plug in for k is 1. So k squared minus 1 would be 1 squared minus 1. Well, that would be what? 0. So the first term is 0. Well, now I want the second term. So I'm going to plug 2 in for k. So k squared minus 1 becomes 2 squared minus 1. So that would be 3. And then I could do that again. The third term, so k squared becomes 3 squared minus 1. So that would be 8. I mean, just by looking at the expression, all you're doing is taking a perfect square and you're subtracting 1. See, the perfect squares would go 1, 4, 9, and then so on. Minus 1, minus 1, minus 1. So does anybody want me to keep substituting, or can we just use the pattern now? What's the next perfect square? 16 minus 1. So the next term would have to be 15. So what's the next perfect square after 60? 25. So minus 1. And then after 25? 36. So that would be 35. And then, of course, you know, it could keep going. Okay. All right. So let's go ahead and figure out what the 100th term is. All right. So a sub 100, that would be 100 squared minus 1. What am I looking at there? Okay, 9,999. 99.99. Here we go. Okay. So as far as the problem goes, the question, it's over. That's all it wanted me to do. Find the first 6 terms and the 100th term. Anybody have any questions about that? No? Okay, so you're probably thinking, okay, how is this going to be arithmetic? Why is it not geometric? Because it would make sense that you're looking more at multiplication than anything else, but let's look at the common difference. Let's take the consecutive terms and see what we get. What's 3 minus 0? 3. 8 minus 3? 5. 15 minus 8? 24 minus 15. And 35 minus 24? 11. So you notice a pattern there, right? Well, here's the thing. The first time you subtract those consecutive numbers, a lot of times that's going to be the same number over and over again. That's your common difference. That's the value of D. Well, sometimes the first time you subtract is not going to be consistent. So if that's the case, you can actually subtract those values again and again until you do get a constant number. See, because this didn't work, we would call this the first difference, the first time I subtracted the consecutive numbers. So if I subtracted them again, I would call that a second difference. So now let's subtract these. 5 minus 3, 2. 7 minus 5, 9 minus 7, and 11 minus 9. See, now I've got a consistent number showing up over and over again. Because it was the second time that I subtracted to get that, I know that my expression has to be a quadratic. It has to be a power of 2. Well, what if the second difference didn't come out consistent? What if it took me to the third difference? Then it would be a cubic function. If it took me to the fourth difference, then it would be a quartic. And it can actually go pretty far sometimes. Now, in order to figure out the k squared minus 1, from here, what you want to do is create a system and then solve for the coefficients. Okay. So at some point, I'm hoping I can come back and actually show you that, but I did want to go ahead and at least take the time to show you how this is arithmetic. Is everybody okay? Questions? Okay, so you can have multiple differences. If the first time you subtract, like on the previous example, the one that had the, what was it, 5, 8, 11, and so forth, if that's consistent the first time, the power is 1, that's why it's linear. Okay. All right, here's our last problem. The fifth term of a sequence is 20, and the ninth term is 36. Write the first few terms and then find a formula for the nth term. Okay, so on problems like this, what I like to do is go ahead and kind of map it out. So 1, 2, 3, 4, but I know the fifth is 20. That's a sub 5. And then 6, 7, 8, we know the ninth is 36. Okay, a sub 9. All right. Now, this is a perfect example. It doesn't tell me if it's arithmetic or if it's geometric. So this is one of those times where you'd have to go ahead and say, okay, I'm going to go with one of these first. If it doesn't work, well, then I know it's got to be the other one. It has to be arithmetic or geometric, right? There's only two choices. And unfortunately, like I said, there's no straightforward method to immediately tell, not that we're looking at right now. So in this case, I'm just going to go ahead and tell you it's arithmetic. Okay. So let's do this. I need to find the common difference D. I need to find the value that I'm going to add over and over again to get from 20 to 36. Okay. So anybody have an idea? How can I find that? What can I do with the two terms that I have? Okay, so Jack says find the difference. So I'm going to take 36 minus 20. Well, that's going to give me 16. So it takes 16 to get from this 20 to this 36. But what am I going to divide by? Okay, I heard 4. I heard 5. It is going to be 4. Because, see, I would have to add once, twice, 3 times, 4 times to get to the 36. So if I divide by 4, okay, well, it looks like my common difference should be 4. Okay. So that's one way to do it. I want to go ahead and show you different ways, just in case one is a little unusual to you. There's another way. You could actually do it more algebraically. Let's say we don't know what the value of D is. Okay. But would everybody agree that the sixth term, it would be equal to 20 plus D? Just the previous term plus whatever that is. Okay. So in order to get the seventh term, that would be 20 plus 2D. See, plus D and then plus D, right? So this one would be 20 plus what? Plus 3D. And then this one would be 20 plus 4D, which also makes sense why we had to divide by 4, right? Okay. But see, I know this expression has to equal 36 because that's the term number. So I could use that to go ahead and create an equation. I could say 20 plus 4D is equal to 36. And the first thing, what happens when I subtract 20? 4D equals 16, divide by 4. See, I'm still getting the common difference to be 4. Okay. So there's going to be multiple ways to do this. Okay. So in fact, what would the sixth term be? 24, 28, and 32, because then plus 4 gets me to the 36. And it should work out perfectly if you've gotten the correct value. Okay. Now, what can I do to get the previous ones? Yeah, if I were adding to get the later terms, then I could subtract to go ahead and get the previous terms. But I'm not going to go ahead and show you how to do it that way because you could realistically come across a problem that says, okay, this is the 200th term, for example. What's the first term? And like in that instance, you're probably not going to want to go back 199 times to figure out what the first term is. So I'm going to go ahead and show you how to do this algebraically. We're going to use that same formula. A sub n equals the first term plus the number term minus 1 times the common difference. Okay. Well, we're looking for the first term. We don't have any idea what it is. Let's go ahead and use one of these. It actually doesn't matter. I could use the fifth term or the last term because I know those for sure. I mean, I could even use the other ones. But let's go ahead and stick with one of the two that we were originally given. Let's say I'm going to go ahead and use the fifth term. Well, what's the value of n? N would be 5 because we're using the fifth term, right? So a sub 5 would equal, we have no idea what the first term is, plus 5 minus 1. I'm just going to go ahead and plug the 5 in there as well. So that's 4. And what's the common difference? 4. Remember, we found that to be 4, right? But here's the thing. If I'm actually using the fifth term, Couldn't I actually just go ahead and plug in the term itself? So whatever the first term is, if I add 4 times, it should get me to the fifth term, 20. So whatever this is, plus 4, plus 4, plus 4, plus 4. See, I did have to add 4 times. So, in fact, what is the first term? 4. Okay. And let's say that should be 8, 12, 16, and it gets you right back to 20. No, you don't need a restriction on the explicit. No. Okay. Now, you're not going to end up with a negative term. I mean, the lowest we're going to go is 1. So, I mean, technically there would probably be a restriction, but it's not required for explicit. Recursive, yes. Okay. All right, how we doing? Anybody having a hard time? Okay, then that's all I got. And that's good because it looks like the bell is about to ring. Okay, so tomorrow I'll pass back those exit tickets. We'll talk about any questions you might have. We'll have a focus activity, and we'll just see how much further we can get on the notes. All right, you guys have a great day. Please don't forget my calculators on the way out.